Okay guys, and welcome back. So what I wanted to do in this video is give you some more examples of recursive methods, some methods that are calling themselves, and talk about like how to set them up. Okay, so some more examples. The first one I wanted to look at was a problem we've seen somewhat before, is how do we reverse a string? So this method will input a string and then return the reverse of it. So if I call reverse and send it like computer, it should return, okay, whatever that is backwards, so that's retup mock. Okay, so that's my goal. So let's go ahead and write the method. So it's a public static string method called reverse that's going to input some string. We'll just call that our original. Okay, so let's kind of think through this. So when you're doing these, you want to think about really just the two things. So what is the base case, which is the simplest possible case? And usually when we're thinking about base case for one of these methods, think like 0 or 1. So for example, if you have a string with a length of 1, and I ask you to reverse it, what do I do? Well, in this case, literally nothing, right? If you have a string with a length of 1 or 0, it's already reversed. So if the length is equal to 1 or 0, just return that string. It's already reversed. So that'll be my base case. So if original.length is less than or equal to 1, well, in that case, then I'll just return the original. Okay, now how else could I return this? Well, I guess the other way I could do this is I could just do one letter at a time. So thinking about this, how would I reverse it? So let's say I want to reverse like computer. So one letter at a time, and I'm just going to do one step at a time. So this is going to be like my recursive call. And again, there's no loops. You're never going to have a loop in one of these methods. You're just doing one letter at a time and letting the recursion take care of the rest of the process for you. Okay, so what I'll do here is, let's see, so I'm going to put an R, so I'll just do one letter at a time and move the last letter to the beginning. So R plus, and then I'll do the rest. So then the rest of it will be compute. Okay, and then I'll do the last letter one at a time. Okay, E, and then I'll check the rest of it, comput. Hey, that actually sounds pretty good, right? So I'm going to basically move the last letter to the front, plus, and then I'll do the rest. Now, I want to point out that this recursion usually comes in the return statement. Now, I guess it doesn't have to. You could do it as part of like a separate string and then return that string, but usually it's going to be somewhere in this case to say, okay, so I'm going to just put the last letter at the front and then recursively reverse the rest. So when I'm trying to reverse this string, I'm just going to put the last letter at the front, so original.substring. You know what, let's have a variable for the length. It doesn't matter. Substring. Well, it'll probably be easier. Okay, so let's set up an int for last, and that'll be original.substring. Oops, original.length minus 1. So that's the last character. So I'm going to take the substring from the last to the end, plus, and then I'm going to recursively check. I'm going to try and reverse the original.substring from 0 to the last. Okay, so let's see if this makes sense. So I'm putting the last letter at the end, and then I'm reversing the rest. And then I put the last letter at the end, reverse the last. Okay, so that makes sense to me. And then when I get down to one letter, right? When I get down to, so I should go over here. I should be clear that here we're like calling a reverse on this. And then we're calling a reverse on this. And then when we get down to the very last case, you know, we put the T, the U, we get down to C. When I call reverse on that last letter C, it's just the letter C, right? That's it. And then we kind of work our way back up the chain, and it should be like, you know, R plus E plus T plus U and so on, and then we do this. Okay, let's test that and see if it works. Okay, so I'll test the reverse computer. Oh, it worked. Beautiful. Okay, and maybe I'll test it on a shorter string. You know, maybe I'll test it on just a one-letter thing, and that should be pretty easy, right? Because if I test on a one letter, it should go right to the base case and just return that one letter. Okay, great. So let's go on and take a look at a couple other ones. Next, I wanted to think. Here's a simple one. Is it a palindrome? Okay, so if I want to check if something is a palindrome, then in that case, well, let's go ahead and start with a string again. So this is going to be a public static. It's going to return a Boolean for some string is palindrome. Okay, and in this case, let's see, I'm going to input a string. Now, just to remember, just a reminder, a word is a palindrome if it is the same forwards and backwards. Okay, so this is a case that's going to be a little more complicated. It's a Boolean, so I basically need to have one base case for if it's true, and then one base case for if it's false. Okay, and then otherwise, I'm going to do the recursion. And I need to make sure that like it's possible to return true and false. Okay, so how will I do this? How will I know if something's a palindrome? What is like the easiest possible thing? Okay. Oh yeah, I'm a real idiot here. This just returns one type. Okay, so how do I make sure that a method returns true? Well, a palindrome, what is the easiest possible palindrome? One letter, right? If I have a string that's one letter or two letters, yeah, it's automatically going to be a palindrome. Okay, so I'll say if, word.length is less than or equal to 1, then I'll go ahead and return true, right? The word I or the word a, those are palindromes. They're the same forward and backwards. Like a or, aha or race car. Like words that are the same forward and backwards are palindromes. Okay, now what else can I do? Well, when would it not be false? So it would be not a palindrome if the first and last letters are different. Okay, so if I take the first letter, so if I take word.substring from 0 to 1, if that is not the same as the last letter, so I got to use exclamation dot equals because it's a string, I don't want to use equals equals. So if the first letter is not the same as the last letter, so that would be word.substring from word.length minus 1 to the end. So if they're not the same, then in that case, I return false. So I have one base case for each possible thing. Now, otherwise, so as long as the first and the last letters are the same, then I'm going to cut them off and check the rest. So basically what we're saying is, okay, if I have race car, I'm going to say, okay, the R and the R are the same. So I'm going to go ahead and cut those off, and then I'm just going to check a Seba. Okay. Now then, okay, the A and the A are the same, so then I'm going to check Seb. Okay, so now when I get to this point, the C and the B, the first and last one are different. So in that case, I would return false. Now, if it did work, so that's bad, but if it did work, if I had race car, here the R and the R are the same, so then I'd have a Seika. Okay, the A and the A are the same, so then I have sec. The C and the C are the same. I get down to E. That's just one letter, so I would return true. Okay, oops, sorry. So that's kind of the process there, that I'm just going to keep checking and work my way down. So I'm going to keep cutting off the first letter and the last letter until I either get to a point where they're different, or I get to the point where it's very short, where I have no letters left, where I have one letter left. Okay, so then what I'll do to cut those off, I'm just going to call this again, so I'll just call is palindrome, and I'll send it everything else. So I'm going to cut off the first and last letters, so I'm just going to take the substring of word from 1 until the end, so I'm going to go length minus 1. Okay, now when you're testing something like this, you want to make sure you test it on several possible cases, right? You want to make sure you test on something that is a palindrome, like race car. Okay, good. I'm going to test it on something that is not a palindrome, Bobby. Okay, good. I'm going to test on something that's close to a palindrome. So maybe it'll work for so maybe something that'll work for a little bit, but not forever, like that race bar, and hopefully that doesn't work. Good, it returned false. Excellent. Okay, so that's what's going on there. Only one more method I wanted to show you guys. This is something that's like really stupid to do with recursion. Like you should do this with a loop, not recursion. Well, let's have a method. This method will count how many Y's are in your word. So if I call like count Y and I send it like hello, that should be 0. Okay. And then if I send it like count y, and then I send it like yellow yay, that should be 3. Okay, now you could do this a couple ways. You could do this with index of, and then just cut off. But you can also use substring. Now, again, I want to point out this is a method you should really write with a for loop. But anything you can do with a for loop, you technically can also do with recursion. And I want to show you a strategy of how. Okay, so let's go ahead and get started. So this is going to be a public static method. It's going to return an int for not palindrome. I don't know what I'm thinking. Count y. Okay, and we're going to input a string for a word that we're going to count. Okay, so what I'm going to do in this case is my simplest possible case is word has a length of 0. Right? If you have a length of 0, that'll be fine. So if word.length is 0, you obviously have no y's in here. So in that case, you would just return 0. Okay. Now I'm going to put a parentheses and squiggly like I'm not a terrible coder. Cool. So now if that doesn't work, then your general strategy is to just look at one letter at a time. Okay. So and generally the easy way is just look at the first letter. Okay. So if that is a y, count it and then look at the rest of it. So if that word dot substring 0 to 1, so if that first letter is a y, then what I'm going to do is I'm going to basically count 1 for that letter plus the count from the rest of the word. So if that first letter is a y, I'm going to return 1 for that y plus, and then I'm just going to call count y on the rest of the word. So I'm going to send it word.substring from 1 to the end. Okay, now the else statement here is representing what if the first letter is not a y. Then in that case, what I'll do is I'm just going to go ahead and return the rest of it. So if the first letter is not a y, I'm basically saying, okay, I'm going to return, well, screw it. The first letter is not a y. Let's just keep checking and check through the rest of it like this. Okay, now if it helps, you could just say, hey, I didn't find a y, so I'm going to put a 0 plus in front, but you certainly don't need to do that. So I'm just saying, okay, if the first letter is a y, I do 1 plus, and then I'll check the rest. If it's not a y, I'll do 0 plus, and then I'll check the rest. Let's test this on a couple cases. So when you test something like this, test on something that's got some y. So yay, chef 3, good. And I said to y-a-y-y. I could check this on something that doesn't have any, like banana. Oops, with a semicolon, and that should be 0. Okay, cool. So that's just hopefully a way to get you used to recursive thinking. I hope this helped, and I'll see you in class. Bring me some questions, and I'll bring you some recursive jokes. Thanks for watching.